Hello, welcome to the second part of our first lesson in our trigonometry unit for our grade 11 University College math class, trigonometry. We've already just gone over sum of interior angles, Pythagorean theorem, and what the primary trig ratios are, and I guess not really how to memorize them, but just sort of when to use them and how to use them. So what we're going to do in example 3 and 4 is we are going to set up some right angle triangles and state the three primary trigonometric ratios for from angle A, and then we're going to find the measure of angle A. So the way that we're going to do it is we are going to start here by looking. Now our reference angle, they've told us it is angle A, so I usually just draw a little something in the corner there to indicate angle A is my reference angle. Now from here I can recognize the hypotenuse pretty easily, in that it is across from my 90-degree angle. The next side that I usually label is the one across from my reference angle, and that one is the opposite side over here. And last but not least, that leaves us with adjacent down here, which, as I've said a couple times, means beside our reference angle, but not the hypotenuse. So there are our three side lengths. Let's get to the primary trig ratios. So we know that the sine of angle A will be equal to the opposite side over the hypotenuse. So we just go to our triangle and we find our opposite side. That has a length of 12, and our hypotenuse, which has a length of 15, and we just pop these in here. Now when you're expressing primary trig ratios, the thing that you want to do when you're leaving them in fraction form is to always have them in lowest fraction form. So for us, we're going to reduce this fraction. So instead of 12 over 15, we are going to divide both the numerator. Well, I'll write that little step in. I'm going to divide both the numerator and the denominator by 3 to reduce my fraction down to 4/5. So the sine of angle A, I don't always write that sort of like little sideways triangle thing. I'll often just write the sine of A equals 4/5. It is important, however, to have this A here. Sine equals 4/5 is not a primary trig ratio. It's just a set of numbers. It doesn't mean anything. Since the 4/5 comes from a specific angle, and in this case, the angle is angle A. Let's try the same thing here with the cosine of angle A. So from our memory banks, the cosine of angle A is equal to the adjacent side over the hypotenuse. So again, if we're writing this out, we're just going to go look at our triangle. My adjacent side is going to be 9. My hypotenuse is 15, so that will be 9 over 15. And as before, I'm going to reduce this down to lowest fraction form, which will give us 3/5. And again, for those who want to see it, what I've done to make this equivalent fraction is I've divided both numerator and denominator by 3. And again, as I'm writing out my final answer, I'm not just writing cos, because it is the cosine from a specific angle, angle A, that's equal to 3/5. And finally, the tangent ratio from angle A is equal to the opposite over the adjacent. So let's go reference our triangle again. The opposite side is 12, the adjacent side is 9, so we have 12/9, and we're going to reduce this down as well. Let's divide both numerator and denominator by 3, and that's going to give us 4/3. And that is, as I've said a few times, that's the tangent from this reference angle A. Not just tangent, but the tangent of angle A is equal to 4/3. So these are the three primary trig ratios for this triangle ABC using A as a reference angle. Now, you know what, I'm actually going to leave this find the measure of angle A part for another lesson. I don't want to lump a whole lot of stuff in here. Let's just get the primary trig ratios down today. So let's not worry about finding the measure of angle A. Let's just move on to example number 4. So example number 4 says solve the following triangle. So again, we are going to start by choosing a reference angle, and just like last time, I'm going to choose angle A. There's our nice angle A. And from angle A, I'm going to label all three sides of this triangle. Hypotenuse, again, pretty straightforward and easy to see. Opposite side is the one across from my reference angle, so that would be opposite over here. leaving us with adjacent down over here. So what you'll notice is that we've been given the opposite side length, 3, the adjacent side length is 4, but we don't have the hypotenuse. So let's go find that side length right now. Because we're looking for a hypotenuse, we can use the Pythagorean Theorem. So c squared will be equal to a squared plus b squared. And in this question, that's 3 squared plus 4 squared. Let's keep working our way down. Again, you can just jump right to the squaring and sum in the same step. That gives us 25. And now we take the square root of both sides to leave us with c equal to 5. So now we have a value for c over here, which I'm going to write in like this. So I know the question says solve the following triangle and round your answers to the nearest tenth of a unit if necessary. We're just going to set up the 3 primary trig ratios one more time. There's no need to hurry through this. We have lots of lessons and lots of time to solve triangles. Let's not put the cart before the horse. So let's set ourselves up the sine ratio. I feel like changing up my colors here. So let's do the sine of angle A. It's going to be equal to something. So what I'd like you to do here, hit pause in the video, and I'd like you to try to fill out what the sine of angle A is for this particular triangle. When you're so hit pause. When you're done, come on back, and we'll see how you did. Okay, you're back. Sine of angle A will be equal to the opposite side length over the hypotenuse. And that will be, in this particular triangle, the opposite is 3, and the hypotenuse is 5. And that is our reduced primary trig ratio for the sine of angle A. Let's try cosine now. The cosine of angle A will be equal to, well, let's let you try it. So give it a try, hit pause here, see if you can figure out what the cos of angle A is. When you're done, come on back, we'll see how you did. Okay, so the cos of angle A is equal to the adjacent side over the hypotenuse. The adjacent side in this triangle is going to be 4, and the hypotenuse is going to be 5, and that is already in lowest form, so the cos of angle A would be equal to 4/5. Last but not least, we have the tangent of angle A. So again, hit pause here, you try to figure out tangent of angle A. When you're done, come on back, we'll see how you did. Alright, the tangent of angle A is equal to the opposite side over the adjacent side. As we look at our triangle, our opposite side is 3, our adjacent side is 4, so we know that tangent of angle A is equal to 3/4, and that's reduced and in lowest terms. So that is our first lesson on trigonometry. It focused primarily on the primary trig ratios and the Pythagorean theorem. In our next lesson, we're going to be looking at using the primary trig ratios to find side lengths and angles. So good luck with the homework, and I'll see you in lesson number 2.